In this corner, weighing in at over 2 million tons, it's space weather. And in this corner, it's Challenger, weighing in at a truly astronomical 1 quadrillion tons, it's supervolcanoes. These two have been going at it for years, but recently the action has really heated up. You may have heard about this crazy lightning show that lit up the night sky over New Zealand in March. That was space weather. Then, in April, a powerful eruption sent ash 25 kilometers into the air in Siberia. That was a supervolcano, but could space weather cause an even bigger explosion? Let's get to the bottom of it. I think we need to start with a quick refresher on our two contenders. Space weather refers to all the ways our sun influences the Earth's environment. In other words, it's all the stuff coming from the sun that hits the Earth. It can be as simple as sunlight or as complicated as charged particles bundled up in a solar wind. This stuff doesn't hit us evenly. When a solar wind slams into Earth's magnetic field, it triggers a geomagnetic storm, which is space weather's way of saying we've arrived and we're here to stay. Geomagnetic storms can mess with communication and power grids and knock out satellites. They can also spark massive volcanic eruptions. That's right, volcanoes have magnetic fields too. Deep inside the Earth's rocky outer layer, aka the mantle, there's a churning sea of molten rock called the magma ocean. Because it's so hot, the magma ocean's minerals become slightly magnetized, aligning themselves with the Earth's magnetic field. This makes Earth a giant magnet. Normally, the Earth's magnetic field protects us from the sun's charged particles, deflecting them away like a force field. But during a geomagnetic storm, the sun's energy is so intense that it overwhelms the Earth's magnetic field. So some of those charged particles manage to burrow into the planet, sinking deep into the mantle where they meet those uncharged magma sea minerals. Now things get weird. The charged particles in the solar wind cause the aligned magnetic fields of the minerals to flip their polarity. Basically, they turn from north to south or south to north. Those tiny flips make local magnetic fields that are similar to Earth's global magnetic field, but weaker and shorter-lived. These temporary magnetic fields are called magnetic domains. They're also key to unlocking the secrets of how space weather influences volcanoes. That's because the charged particles don't just align the minerals' magnetic fields, they also heat them up. This causes the surrounding rock to expand, building up pressure until, bam, volcanic eruption. Studies have shown that geomagnetic storms can trigger earthquakes and volcanic eruptions by influencing the electrical charges within the Earth's crust. For example, a study published in 2021 found that 4 out of 5 volcanoes studied in the Philippines had increased seismic activity following a solar storm. However, one volcano, Mount Pinatubo, went from calm to erupting in just 3 days. What's more, the charged particles from space didn't just trigger Pinatubo. They also caused the lava to be more viscous, which led to more explosive eruptions. But while scientists have known about this link between space weather and volcanic activity for a while, the exact mechanism behind it has been a mystery. That is, until now. A new paper published in Nature Communications proposes that it's those fleeting magnetic domains were actually responsible for the eruption. To come to this conclusion, researchers recreated various space weather scenarios using a spherical device filled with liquid metal and embedded with 360 sensors. By applying a magnetic field to the device and suddenly switching the polarity, the team simulated a geomagnetic storm. As expected, the liquid metal initially flowed in one direction, but then it quickly reversed. What they weren't expecting was the chaotic swirling motion that followed. Turns out when the polarity flipped, it generated electric currents within the liquid metal. Those currents produced magnetic fields that were in direct competition with the Earth's magnetic field. The result, those fleeting magnetic domains. By measuring the strength and duration of these magnetic domains, the researchers could model how a geomagnetic storm would impact a magma sea. Based on their experiment, they predict that these magnetic domains could lower the melting temperature of rocks in the mantle, causing them to bubble up and mix with the magma ocean. If the magma ocean is already close to its boiling point, that's enough to trigger an eruption. Now let's bring in the big guns. To test their hypothesis further, the team turned to NASA's supercomputer to create a detailed 3D model of Earth's mantle. Using this model, they simulated how a solar storm would influence magnetic fields and temperatures deep within the planet. Once again, they saw the formation of magnetic domains that caused rocks to melt and mix with the magma ocean, which built up pressure and eventually erupted. The researchers believe this model accurately simulates what happened in Siberia in April. While they don't know the exact details of the eruption, they do know that there was a strong geomagnetic storm shortly beforehand, which may have triggered the eruption by creating these fleeting magnetic domains. So space weather can absolutely trigger supervolcanoes, but can a supervolcano erupt just because of space weather? Well, maybe. See, while a single volcano might not be able to take down Earth's magnetic field, a supervolcano certainly can. That's because the amount of rock and ash ejected during a supervolcanic eruption is so great that it can block sunlight and drastically cool the planet. For example, the eruption of Mount Pinatubo in the Philippines in 1991 is estimated to have ejected 5 billion cubic meters of ash and rock into the atmosphere. That's enough material to cover the entire United States with 2 centimeters of ash. Ash is made of tiny rock and glass shards, which are made of silicate minerals. These minerals are the same ones that make up Earth's mantle, and they behave like tiny magnets. After an eruption, as these magnetic minerals rained back down to Earth, they aligned themselves with the planet's magnetic field. Effectively, this made Earth a stronger magnet. Over the next few years, the extra magnetic pull bounced the charged particles from the solar wind away, protecting Earth from further damage. Scientists estimate that the Pinatubo eruption caused a 7% increase in Earth's magnetic field strength. And while that sounds small, it's actually enough to explain why the frequency of geomagnetic storms decreased by 40% after the eruption. This means that a sufficiently large eruption can not only withstand the brunt of space weather, it can actively fight back. Imagine if the Earth's force field got a serious upgrade just from the minerals raining down after a super eruption. It could bounce space weather away before it ever reaches our atmosphere. Unfortunately, the opposite can happen too. A weakened magnetic field can lead to more extreme space weather, potentially triggering more eruptions. It's kind of like how scientists have predicted that the next solar maximum will likely be extremely intense. This has led some to speculate that we could see more volcanic activity in the near future. But predicting volcanic activity is tricky, since even with modern instruments, we can only detect about half of the volcanoes that are actively bubbling beneath the surface. And while we know the strength of the Earth's magnetic field, we don't exactly know how much of an influence space weather has over each individual volcano. Every volcano is different and has its own unique set of circumstances that could either amplify or dampen space weather's effects. For example, Mount Ibu in Indonesia sits right on the equator where the Earth's magnetic field lines are nearly horizontal. That means that charged particles from a solar storm don't have to travel far to reach the local magnetic domains generated by the volcano. Meanwhile, Mount Vesuvius is located at about 41 degrees latitude, which is far enough away from the equator that the Earth's magnetic field lines converge downward. Charged particles hitting the Earth's surface near Mount Vesuvius are more likely to bounce off rather than dive into the planet. All of this is to say that while there is a relationship between space weather and volcanic activity, it's complicated. There are a lot of factors at play, and based on what we know today, we can't say that space weather alone can trigger a supervolcanic eruption. However, thanks to this new research, we're one step closer to answering it. And that's 1 minute.